Hey folks, I worked through a video solution here for most of the items on practice test number 2. Not going to do every single one, but I'll do most of them. I thought we'd start with number 1. Number 1, you were given the two functions, f of x equals 4x minus 3, and g of x equals 2x squared plus 14x plus 3. In part A, I asked you to evaluate the f divided by g of 5. And then in part B, determine and simplify f divided by g of x. So let's get started here with part A. To do the f divided by g of 5, keep in mind that's nothing more than f of 5 divided by g of 5. So to get f of 5, remember you're going to take 5, and you're going to toss it into function f wherever you see an x. So we're going to take 5 and put it in here for x. 4 times 5 is 20. 20 minus 3 is 17. So the f of 5 is 17. To get g of 5, we're going to put 5 into function g wherever we see an x. So a 5 would go there and a 5 would go there. And, you know, when I do a 2 times 5 squared plus a 14 times 5 plus 3, I crank that through my calculator, I get 123. So the f divided by g of 5 is 17 over 123. Now in part B, to get the f divided by g of x, well folks, it's just taking f of x and dividing it by g of x. That's all it is. So what's f of x? It's 4x minus 3. And what's g of x? Well, g of x is 2x squared plus 14x plus 3. And for this one, there's no simplification that could take place. If I'd done f times g of x, I would then actually multiply it out, but there's nothing more I could do there. So that's it for number 1, part A and part B. Okay, here in number 2, I asked you to use the functions f of x equals 4 over x plus 3, and g of x equals 5 over 6x. And I asked you to find the composite function f composed with g of x, or the fog of x. So remember, to get the fog, or f composed with g of x, you start off by rewriting it as f of g of x. And that's a matter of saying, okay, the f of g of x, well, what is g of x? G of x is 5 over 6x, so we put that in here for g of x. And now we're being asked to find the f of 5 over 6x. It's just evaluating a function. We have to take 5 over 6x, toss it into function f wherever we see an x. So that would give us this mess, taking 5 over 6x and putting it in here for x, gives us a 5 over 6x plus 3. Okay, now this looks horrible. I mean, this is like a complex fraction. You know, I hate fractions, so I really hate complex fractions. I mean, there's a fraction in the denominator of this fraction. I mean, that looks horrible. So a quick thing to do now is, this is kind of like the simplifying part, is just go ahead and multiply the numerator and denominator by 6x. If you multiply the numerator by 6x, that gives you a 24x. When you multiply the denominator by 6x, remember you'd be using the distributive property, so each term here would get multiplied by 6x. So 5 over 6x times 6x is 5, and then 3 times 6x is 18x. So the f composed with g of x, or the fog of x, is 24x over 5 plus 18x. And that's all there is to number 2. All right, folks, before we do number 4, I thought I'd quickly talk about number 3. Number 3 asks you if the function f of x equals the opposite of the quantity x plus 3 squared is 1 to 1, and to explain your answer using a complete sentence. Well, if you look at the graph of the opposite of the quantity x plus 3 squared, you're going to see what you're going to see is that the graph does not pass the horizontal line test. So that means the answer to number 3 is it is not 1-to-1. And the reason why is it is not 1-to-1 because it fails the horizontal line test. So that would be it for number 3. Here in number 4, I give you a function f of x equals 2 over 7x minus 3. And I ask you to determine the inverse function, f inverse of x. So this is going to be going through our 4-step process on how to find an inverse function. Remember step 1, you're going to take f of x and you're going to replace it with y. So that gives us y equals 2 over 7x minus 3. Step 2, we switch all the x's and y's here. So I turn that into an x and I turn that into a y. That's step 2, switching the x's and y's. Step 3 is I have to take this equation and I now have to solve that for y. Well, here's how I'm going to solve it for y. I'm going to start off by multiplying both sides of this equation by 7y minus 3. That gives me x times 7y minus 3 is equal to 2. And now I can distribute this x to get a 7xy minus 3x equals 2. Now keep in mind I'm trying to solve for y, so I want to end up getting y by itself. So my next step is going to be add 3x to both sides of the equation. And I'm running out of room here, so let me tag it up here where I have a little extra space. I'm going to add 3x to both sides. So that gives me a 7xy equals a 3x plus 2. Now it looks like I have one more step to go in order to solve for y. And that will be divide both sides of the equation by 7x. So I divide both sides by 7x. And I'm now done with step 3. I have solved for y. And then remember step 4. Step 4 is replace y with the appropriate inverse function notation. In other words, our function was called f of x, so the appropriate inverse function notation would be f inverse of x. So I replace y with f inverse x. And that's it for number 4 on determining an inverse function. Hey folks, here in number 5, I gave you a quadratic function, f of x equals x squared minus 8x plus 7. And I asked you to do 4 things. In part A, I asked you to determine the coordinates of the vertex. Part B, get the x-intercepts. Part C, get the y-intercept. And then part D, sketch a graph using the information we gather in parts A, B, and C. So here we go. Get the vertex. Remember when your quadratic function is in the form, this form, ax squared plus bx plus c, we have that handy-dandy little formula to give us the x-coordinate of the vertex. The x-coordinate is negative b over 2a. So that would be, well, the opposite of negative 8 is 8. A is 1. So we have the x-coordinate of the vertex is 4. Now we need to get the y-coordinate of the vertex. Remember, to get the y-coordinate of the vertex, you take the x-coordinate and you toss it into the function for f. In other words, you're evaluating the function at 4. And see, 4 squared minus 8 times 4 plus 7. Oh, good grief, that gives you a negative 9. So that means the vertex, the coordinates of the vertex, are 4, negative 9. So that's the answer to part A. We know the vertex is at 4, negative 9. Part B, determine the x-intercepts. Well, remember in general, to find x-intercepts, you let y equal 0. So that means you have to put 0 in here for f of x. And you have to solve this equation. Helps if I have it as a plus 7. And I think this factors pretty quickly to x minus 7 times x minus 1. Set each factor equal to 0, and you get x is 7 and x is 1. So the x-intercepts are at 7, 0 and 1, 0. So that's the answer to part B. In part C, to get the y-intercept, well, remember, to get the y-intercept, you're letting x equal 0. So you toss 0 in for the x's, out comes 7. So let me, that was quick to find the y-intercept, 0, 7. And now part D, sketch a graph, and we're going to use the information that we gathered in parts A, B, and C. So let's start off by plotting the vertex. It's at 4, negative 9. 1, 2, 3, 4, negative 9. I scaled my y-axis by 3s. It's negative 3, negative 6, negative 9. So I'm going to say about right there is the vertex. X-intercepts are at 7, 0, and 1, 0. Well, here's 1, 0. 7, 0. Let's see. 2, 3, 4, 5. Oh, I got to extend my x-axis a little bit. So 1, 2, 3, 4, 5, 6. There's 7, 0. And my y-intercept's at 0, 7. Again, I've scaled my y-axis by 3s. So here's 3, 6. That would be 9. So I'm going to say 7 is about right there. And those 4 points should be enough to sketch a graph of this quadratic function. Because remember, A is positive. It means the parabola has to be a happy parabola. So I'll just sketch a happy parabola through those 4 points, and I'll call that a nice sketch of the graph. And then I could always use my graphing calculator to check to make sure I see something like that. But that's it for all the parts of number 5. All right, hey folks, on number 6, I've given you the graph of a quadratic function. I didn't draw it up here because, well, you can see the graph on the practice test. It's a nice looking graph. But I told you that the vertex of the quadratic function was 1, 9, and the y-intercept was 0, 8. So I just wrote that information down here. Vertex is 1, 9, the y-intercept is 0, 8. First thing I noticed, before I look at anything else, the parabola is a sad parabola. And because it's a sad parabola, I know A has to be a negative number. All right, now let's see what I asked you to do in parts A, B, and C. In part A, I asked you to use the coordinates of the vertex to write the function in the form f of x equals a times x minus h quantity squared plus k. Well, that's a one-step problem. You get a times x minus 1 squared plus 9. That's it for part A. But now part B, I ask you to use the coordinates of the y-intercept. 0, 8. Use the coordinates of the y-intercept to determine the value of A. So we're going to use the coordinates of the y-intercept to figure out what A is. So here's where we're at. We have f of x equals a times x minus 1 quantity squared plus 9. And we're going to use the coordinates of the y-intercept to determine A. Well, keep in mind, this is x, this is y. So why don't I go ahead and put 0 in for x and put 8 in for y. That gives me 8 equals a times 0 minus 1 squared plus 9. I should be able to solve this for, it should be easy to solve this for a. Because 0 minus 1, well, that's negative 1. Negative 1 squared is positive 1. So a times 1 is a. Subtract 9 from both sides, you get negative 1 is equal to a. So that means we're done with part B. Part B asked us to just find the value of a. Then in part C, It's like, well, let's go ahead and write, I asked you to go ahead and write the function of the graph in this form. Well, put it together. Part A gave us this. Part B tells us A is -1. So if I take A as -1 and I put it right here for A, I'm starting at this point. That's putting -1 in here for A. Now to take this function and get it into this form, well, all I have to do is FOIL the x minus 1 squared. So I take x minus 1 times x minus 1, and that gives me an x squared minus 2x plus 1. And then, I shouldn't forget the plus 9. Now this negative, I'll go ahead and distribute the -1. That gives me a negative x squared plus a 2x minus 1 plus 9. Then I combine my like terms. The only like terms I have are the -1 and 9. So I get negative x squared plus 2x plus 8. And that would be the answer to part C. That's in the ax squared plus bx plus c form. So that's it for number 6. Hopefully this is making sense, and well, I guess next up we'll take a look at number 7. Alright, here in number 7 I tell you that the daily profit that a vendor receives from selling X pretzels is given by this function, that quadratic function. In that quadratic function, X represents the number of pretzels baked and sold each day. So X is the number of pretzels baked and sold each day. And P of X is the daily profit in dollars. So in part A, I ask you in part A to find the number of pretzels that must be baked. I have a typo here, it says backed. Must be baked and sold to maximize profit. So we want to know how many pretzels do we have to bake and sell to maximize profit. That's part A. Then part B asks, well, what is the maximum profit? A and B, both of those together are telling you find the vertex. And how do we know it's telling us to find the vertex? Well, look at this function. It's a quadratic function. We know the graph of a quadratic function is a parabola. A is a negative number, so it's a sad parabola. I don't know what the graph looks like exactly, but I do know it has a shape something like this. That's the vertex. The x-coordinate of the vertex, that's going to tell us how many pretzels we need to bake and sell each day. The y-coordinate of the vertex, that's the profit. That's going to tell us the maximum profit, the daily profit that's maximized. So A and B together is telling us find the vertex. Luckily we have a little vertex formula. Negative b over 2a. So that's a negative 1.6 over 2 times negative 0.002. And yes, I'm going to use a calculator here. That when I do this, negative 1.6 divided by 2 times negative 0.002, I get x is 400. And then I evaluate, to get the y-coordinate of the vertex, I evaluate the profit function at 400. So I'm putting 400 in for the x's, and what comes out is 70. So the answers, to answer each question. Part A, there's the answer. 400 pretzels. That's how many pretzels have to be baked and sold each day in order to maximize profit. The y-coordinate of the vertex, that's the answer to part B. What is the maximum profit? Well, the maximum profit is $70. And I hope for this vendor's sake they're selling something else besides pretzels. because a maximum profit of $70 a day maybe isn't the best business to be in. But in any event, number 7, classic example of an application where the vertex answers a couple of questions. So I hope number 7 makes sense. Alright folks, before I do number 9, I thought I'd talk about number 8. Number 8, you were given the graph of a polynomial function and you were asked 2 questions. In part A, you were asked to determine the degree of the function as being even or odd. Well, since one end is going up and the other end is going down, that's the end behavior of the function, I determine that it is an odd degree polynomial. Now, part B, you were asked to determine whether the leading coefficient is positive or negative. Well, since this end was going up and that end was going down, that tells me the leading coefficient is negative. So for part A, the answer is it's an odd function. Part B, it's a negative leading coefficient. Now, number 9, I asked you to sketch a graph of that polynomial function on, we'll have to graph it on a coordinate plane. I don't know what else you'd graph it on. So when I look at this, the first thing I identify are the zeros of this function. Remember, zeros are found by taking the function and setting it equal to 0. So just by eyeballing it, I would set each of these factors equal to 0. The first one, the first factor, gives me a 0 of 0. And I'm going to make a note, even multiplicity. So let me write that down. Even multiplicity. And we know that implies that the graph will just touch the x-axis. Okay, this factor gives us a 0 of 1. And it only occurs once, so that's an odd multiplicity. So odd multiplicity, and we know that an odd multiplicity tells us that the graph crosses the x-axis. And the last factor gives us a 0 of negative 2, and it occurs once, so it also has an odd multiplicity. So that means the graph will cross the x-axis. Now let's look at the degree of this polynomial. We have an x squared, and here's an x, and there's an x. If I were to multiply this all out, I would have an x squared somewhere times an x times an x. Well, x squared times x, that would be an x to the 4th power. So it's a 4th degree polynomial. That tells me the end behavior, either both ends are shooting up or both ends are shooting down. But this negative here, that's a negative leading coefficient. That tells me both ends are shooting down. So I think I have enough information to sketch a graph of this polynomial. We have the zeros. We have a 0 at 0, we have a 0 at 1, and we have a 0 at negative 2. I know both ends are shooting down. I know at the 0 of negative 2 and the 0 of 1, the graph is going to cross the x-axis because that's odd multiplicity. I know at this 0, it's an even multiplicity, so the graph is just going to touch the x-axis. So I'm going to get a graph that looks something like this. And keep in mind, this is just like a sketch. It's going to do something like this. Here I'm crossing the x-axis at negative 2. Going to come down and just touch the x-axis at 0, bounce back up, and turn and cross the x-axis at x is 1. And that's my rough sketch of this polynomial function. And again, I could fire up my calculator and graph it to see how accurate my sketch is. So I could use my graphing calculator to check. But that's it for number 9 and the analysis that I used to do number 9. Hope it makes sense. Hey folks, the next one we do is number 11. It says use the factor theorem to determine if x minus 7 is a factor of the function x to the fourth minus 45x squared minus 196. Very short and sweet. Factor theorem, remainder theorem, I'm really kind of using both of them together. Remember the remainder theorem? The remainder theorem tells you that if you evaluate the function at 7, what comes out tells you the remainder if you were to crank it through synthetic division. So if I evaluate my function at 7, and at this point I realize, boy, I am so happy I have a calculator to do this numerical work for me. When I take 7 to the fourth minus 45 times 7 squared minus 196, I get 0. That tells me when I take this polynomial and divide it by x minus 7, I'm going to get a remainder of 0. If I get a remainder of 0, that tells me, thanks to the factor theorem, that that is a factor. So since we have a remainder of 0, I'll write this down a little bit. Since f of 7 does equal 0, that tells us x minus 7 is a factor. And that's all there is to number 11. Yeah, I thought the next one we'd look at is actually the last one. Determine the vertical and horizontal asymptotes of this rational function. And I'm going to start with the horizontal asymptote first, because the horizontal asymptotes, remember, that just requires me to compare the degree of the numerator to the degree of the denominator. So the degree of the numerator is 1, the degree of the denominator is 2. So remember, since the degree of the numerator is less than the degree of the denominator, that tells us the x-axis is the horizontal asymptote. The x-axis is known as the line y equals 0. So that is the horizontal asymptote. Y equals 0, also known as the x-axis. Now to determine the vertical asymptotes, well, the key for vertical asymptotes is let's make sure we have our denominator completely factored. And well, that factors to x minus 4 times x minus 8. Now remember, for vertical asymptotes, you want to find all values of x that will make the denominator equal to 0. So look, what values of x makes the denominator 0? Well, x equals 4 and x equals 8. Those are the two values that makes the denominator equal to 0. And then remember the final thing, you find the values of x that makes the denominator 0, and then you see what that does to the numerator. So in other words, x equals 4. That makes the denominator 0. But the numerator would be negative 60. Well, if the denominator is 0 and the numerator is not 0, that tells us x equals 4 is giving us a vertical asymptote. Let's check x equals 8. X equals 8 makes the denominator 0, but when you put 8 in here for x in the numerator, you get negative 56. That's not 0. So 8 is a value of x that makes the denominator 0, but the numerator is not 0. So that tells us x equals 8 is a vertical asymptote. So this function, the graph of this function would have 2 vertical asymptotes and 1 horizontal asymptote. And then to finish this up, remember, if you find a value of x that makes the denominator 0 and it also makes the numerator 0, that's not a vertical asymptote. That's going to give you what's called a hole in the graph. But here you were just asked to identify horizontal and vertical asymptotes. So that's it here for practice test number 2. Hopefully things are going really well for you and it's making sense and you're feeling confident for test 2. Good luck on test 2 and thanks for watching.